All right, everyone, welcome back to, I guess, our second to last lecture. I have one more. We'll see what we discuss. And then the final lecture, I guess, is the one where you guys get to present your projects. So there are 37 folks officially in the class. So, I don't know, we're going to do something where it's like 2 to 3 minutes, and I don't know, I'll send something out to the news group so we can figure out exactly to make sure that we get things moving very quickly. Probably the easiest thing will be for folks to send their projects, and then I'll have them built, and then we'll just kind of fly through folks. The other thing is we'll be able to use the little camera over there for people who want to show off their application on the device. So we'll figure that out. Announcements. I don't know, I guess this is an old announcement. It's due less than 2 weeks from today. So I've seen a lot of good progress. I've seen some folks that are a bit behind, but I guess that's what Thanksgiving will be for after the turkey coma. You can code. So do you guys have any questions, concerns, anything about anything? Okay. So today we're going to look at some more of the tools. If you remember back to the first day, I kind of went through a bunch of different things really quickly. I guess we're sort of coming full circle, and now as you guys approach the end, you might need to look at some of these tools. Although the static analyzer is something that could have been used all throughout, but yeah, so if you're having performance issues, worried about memory leaks, some of these tools will help you out. So we'll start with the static analyzer, and basically the static analyzer helps you find potential bugs at compile time, so versus while actually running the program. So if you haven't heard this in your software engineering courses, or if you haven't experienced this yourself, basically the earlier you find bugs, the better it is, because it saves you time, which means you save money. So I've worked on some projects where a bug that was missed very early on was now affecting the way things worked much later in the project. So now you're not in a position where you can really fix the bug, because all the code expects, all the code that works based on this bug, and making modifications for various reasons were just too difficult. So one of the things that comes to mind was it was like a quaternion math library. So for those of you who aren't familiar with quaternions, it's a generalization of complex numbers, and it lets you do rotations and all these other fun things. So yeah, for whatever reason, something had been implemented in a very, very terrible way, and so this is like a core component that was being used throughout. So it wasn't something that at the time, unfortunately, you couldn't change things. So anyways, so the static analyzer is new as far as Xcode is concerned. It's as of Xcode 3.2, which was released with Snow Leopard, and it uses an open source static analyzer called Clang, or Clang, and that one's actually been around for a little while, but it's sort of finally made its debut in Xcode this summer. So let's take a look at some of what the static analyzer will help us with. And I feel like it's too bright up here. Let's see. Tweak a light. Okay. So let me switch over to my Sorbonne Yellow Large. So what I've done is I've put together a few things that they're a bit contrived, but just to give you a feel for what the static analyzer will help you find. And then there's an open source game engine which I've never used, and I was recently just looking at it, and I thought, well, let me just run the static analyzer and see what I see. and we'll take a look at that and see if we can find any actual bugs, or if they seem like false positives or whatnot. So first things first, let's just run the static analyzer and see what we get. So to run it, it's actually under the build menu. So you do a build and analyze, and it will go ahead and actually run the static analyzer. And if you can see down in the lower corner, so similar to warnings and errors, they appear down here. So this particular symbol is for the static analyzer. So, and also we see them in the gutter, again, just like warnings and errors. So let's start with this particular piece of code, some other message. And so imagine that there's all sorts of code in between where we declared this pointer and we set it to null, and the place where we actually dereference that pointer and assign it something. So clearly this is an error, right? We've got a pointer to null. We don't actually have any memory that we're really pointing to, so we're dereferencing a null pointer. So that should be bad. And if we look, the static analyzer seems to have caught that and says, dereference of null pointer. Okay, that's nice. It seemed to have figured out exactly what was going on. So if you click on that, you will then actually get some additional information where basically it'll show you, it tries to show you a path from where sort of things started, and kind of will walk you through the code and eventually lead you to the point where something bad is going on. And let's see. So if we look up at the top, there's this new little thing that that came up when I selected this particular issue. And so let me see if I can get this all on screen. So if we look, it has two things in there. So right now it's saying variable p is initialized to a null pointer value, and then if we go to the next one, I don't know if you noticed that arrow sort of brightened up, and now the p is, there's like a little box around it. Oh yeah, that's very clear on there. So basically, some of the potential warnings that come up out of the static analyzer, they'll have a list of things associated with them, and you can walk through them either by just through this drop-down menu, or off in the corner there's these little arrows that will walk you through it so you can see what's going on. Okay, so catching null, dereferencing null pointers is one of the things that the static analyzer will do for you. In this case, we can fix that by saying, p equals what? We need to have some sort of character C, and we can say that p equals the address of C. And if we now build that particular, well, let's run the analyzer again, build and analyze. So this time around, this error is gone. So static analyzer will help catch some of those. Let's take a look at another thing that it will help you with, which again, these are very contrived, but imagine having lots more code in there. So in this case, I've got an NS string, and I'm allocating it and initializing it with this hello UCD, and then I'm just printing it. So in this case, based on our usual memory rules, can you tell me before even looking at the analyzer what the issue is? This is an interview question, right? Come on, tick-tock, tick-tock. Right, what do we do with things that we allocate? What do we have to do with them at some point? We have to we have to release them. So in this case, we're not doing that. So if we happen to forget, or we're busy, we're in a turkey coma and coding our apps that are due very, very soon, we might miss this. But the static analyzer will tell us, hey, look, there's a potential leak of an object allocated on line 19, and if you click that thing in the corner, we can get we can look at this and see it in an alternate way to get more, if it doesn't fit on screen or something. So again, if we select it, we'll get some information. In this case, it's saying, okay, usually what you do is you just follow the arrows, and if you look closely, you'll see that some of the arrows are darker than the others. So, and again, there's that drop down that will sort of walk us through what's going on. So right now it's saying, okay, well, we allocated this string, and it tells us that that method returns this Objective-C object with a retain count of 1. And if we now go to the next thing, we see that the arrow kind of went to the next one and sort of to the end of the function, and it's saying that the object that was allocated is no longer referenced, and if we keep reading, it says has a retain count of 1. So again, in this case, we can see that, oh yes, definitely something funny is going on, and we didn't release our string. So my string release should fix that particular issue. So again, build and analyze, and now we're down to one particular issue. So I put together a little fancier example based on an example that I saw Apple give at some point. And in this case, again, it's a little more involved. What they had described as this example is they said that it was found in a large code base that is not open source. So I don't know, read between the lines or something, but I figure it was probably an issue in the OS itself, and they ran the static analyzer on it, and they found this particular thing. In this case, it's been all cleaned up, and it's actually slightly different than what they did, but looking at this, let's spend a few minutes just looking and see, can we see an issue here? So what do we have? We've got, before the static analyzer, very quickly, what do we have? We just have an array of some objects which happen to be these strings 1, 2, 3, and we have this new object that's set to nil, and now I'm just looping over that array, and however many objects are in there, grab the object at whatever index we're at, and then I'm saying, if the object we're looking at happens to be an NSString class, then let's just go ahead and allocate a new NSString and initialize it with this hello. And then it's just, all right, let's go ahead and just log that object. So we'll print it, and then we'll say, well, if the object isn't nil, let's go ahead and release it. So I don't know, anyone see anything weird or potentially weird? So let's see what the static analyzer tells us, because it is kind of, again, another interview question, maybe harder. So, okay, so if we look, the static analyzer tells us incorrect decrement of the reference count of an object is not owned at this point by the caller. So that it seems a bit cryptic, but it's almost basically what this one seems like. It's so in the previous example we had something where we didn't call release, so our retain count was too high. In this case, it seems like what we might be doing is we might be calling release too often. So over-releasing an object. And that's sort of, again, this message seems kind of weird, but so incorrect decrement of the reference count of an object is not owned at this point by the caller. I don't know. It's I've seen some better descriptions, but that's let's go ahead and click this and follow through. So if we look now, we see a bunch more stuff going on. And again, we see if we look at that drop down, we've got about 4 things going on before we kind of get to the sort of the point. So the first step, again, we follow those arrows, and we see that one of the messages here is looping back to the head of the loop. So it seems to be saying, okay, well, if we're in the loop, And in this case, so we've got our object, we go to the loop, we pull an object out of that array, and now, based on these arrows, it seems like what we're doing is we're taking this first if statement, and we are allocating an object that has a retained count of 1. So we own this thing. If we go to the next step, what it's now doing is, again, follow the dark purple arrows. We go to NSLog, and now we hit the next if statement. So if the object is not nil, bless you, if the object is not nil, then go ahead and release it. So it says reference count decremented. And what is that? So we see that this reference count is decremented. And I'm not sure it's got both of these. I feel like the second one refers to the next thing that we're going to see, but let's see. So to me that seems okay, right? We have an object. We've potentially, right, so we've gone through the first if statement and it said, hey, this object is of type class, so let's go ahead and allocate a new one. And now, so we know that our object should not be nil, and so we go in and we release it. So that seems okay. If we now, what's that?
Only in the first pass through the loop.
Yes, only through the first pass through the loop. So now, if we, we go to this third thing, so we see, that what we've now done is we've looped back to the start of the loop, and if we go one more time, we now see that in this case what's happening is the object is not a type of type NS string. So the new object isn't nil because we set it to something previously, and by releasing an object, so saying object release, the system doesn't then say, okay, well, object retain count -1. It then doesn't say, okay, object, since you've been deallocated, if you have been, let me go ahead and set you to nil. So basically what ends up happening, you go through the loop, say, the first time, and you do have an NS string, and you allocate it, and you release it. Well, your pointer is now pointing to this memory that was released. And now you go through the loop a second time, the object isn't nil, so basically we're over-releasing this object. And in this case, the simple fix for that is, after you release it, set the new object to nil. And if we build and analyze that, then it goes away. So it'd be interesting, right, on your project so far to take them and just do build and analyze and see what you see. Now, this thing isn't perfect. It's not, it's not what the folks over in the CS department or some of the folks are doing, where it's like, okay, take a program and let's prove that it's, let's verify and prove that this program is actually correct. It doesn't do anything quite that fancy, but it does do some stuff where it'll go through and figure out what it can. It is limited. It doesn't work across function calls. So if you see all the stuff I've been doing, I've sort of been limiting it to the function that we're in, and that's just sort of the feature set at the moment, where it's just focused on the one method that you're in, and so there are situations where it could lead to false positives. So one of the things, let me see if I have some other samples in here. So if you read through the documentation, you'll see some more about how to use it. But another thing that this will tell you is if you're in a situation where you have a variable and you don't initialize it and you use it, So it could be that there's a situation where maybe you have some if statements and you're always assuming that you're going to actually go through the if statements the way you've set them up, and that object will get initialized in that process. But what the static analyzer will do is it'll sort of try to find all the paths through this piece of code, and it'll find some of the paths that you hadn't necessarily considered, and some of those paths could lead to using maybe the function returns this variable after it's been set in some way, but there's a particular path within that piece of code that doesn't actually set the variable, so then you end up just returning garbage. So the static analyzer will catch stuff like that. So let's take a look at the static analyzer results of this open source game engine that I was looking at. And I didn't do this to bash them or anything. It just happened to be what I was looking at. I don't know how many false positives are in there or what, but the game engine, just so that they can, a lot of people are using it, so just so they can get some recognition there. The engine is called SIO2. So for anyone who's looking for a 3D game engine, it has some integration with Blender, the open source modeling program, and a bunch of other stuff. So I ran the static analyzer, and I don't know, maybe it's not meant to be built with 3.0 or what, but first of all, it's got like 1,330 warnings, so I don't know. I try not to ship with warnings, but that's another thing. The static analyzer itself said that there were 47 issues in this code. So it's always fun, right? Go off, get some open source stuff, and run the analyzer on it and see what you can see. And if you find legitimate issues, go in and fix them and submit them back to the community. That's always nice. So let's see, what are some of the issues we found here? Let's see if we can find, well, hey, dereference of null pointer. That one sounds familiar. That was one of the ones that we looked at. And let's see. In this case, what we see. Okay, so at this point, assuming pointer value is null. So I've never looked through this code besides just kind of running this analyzer. So again, let's see. So long S. So where's our pointer that's being, assuming pointer value, serial no. Okay. So we've got our pointer coming in. And let's see. So if we go through the first if statement, we're dereferencing it, dereference of null pointer. So I guess that seems kind of odd. I mean, so granted this thing, so we have a pointer to a pointer. So first it's saying, if that thing is valid, then, so this to me seems definitely like a bug, right? So we've got a pointer that comes in, and the first thing we're doing is we're saying, hey, if this thing is actually pointing to something, then okay, great, get this OGG stuff. So OGG, if you're not familiar with it, it's like the open source MP3 format, compressed audio format. So this looks like we're in some sort of audio playback type stuff. So so if everything is hunky-dory, then great. But it does seem kind of odd, right? If this particular pointer happens to be, if we go into the else, well, the first thing we're doing is we dereference it. So we're dereferencing a null pointer. So clearly this one seems like an issue to me. Let's see, what else? Value is stored. Maybe we'll see a fancier one. So this one doesn't seem like it's got that much to it. I want to see if we can find a definite, like a false positive. So value to flag is never read. So in this case, we're assigning something to this flag variable, but we're never actually using it. I guess that could be bad. So some of the cases, so what I'm trying to look for is something where oftentimes what will happen is you'll have a piece of code where you're doing some sort of error checking, and you'll have some variables that will only be assigned if there is an error. And so there, I don't know, it seems like the static analyzer will report these things as being, as having some issues where in reality they're not really issues, because as far as you're concerned, those, you don't really want to be using those variables, because all you're doing is, I mean, maybe you're passing them along, but let's see. No. Yeah, lots of dereferencing of null pointers. So let's see, here's an example with some error stuff. What do we see? No, not quite what I was hoping to see. But in any case, grab some open source stuff, run this, or run it on your own code and check it out. It might help you find some obvious memory leaks that you may have missed. So that is, I guess that's all I'll say about the static analyzer. The next thing that we can look at, I guess, is we can move on to instruments. And as far as instruments goes, basically you can use it to help, to help you identify and then hopefully solve various iPhone performance issues. So performance issues related to, another tool for memory allocation type stuff. So maybe you're leaking memory in some terrible way, and the static analyzer maybe misses it. Maybe things are running a little too sluggish; they're too slow. So again, you could use instruments to take a look and see where most of your time is being spent. So I'm trying to think in terms of examples what to run instruments on. I guess we can run it on some of my code and see, and hopefully we don't, I don't know, we'll try not to end up in any of the secret sauce that's broadcast to everyone, but there isn't really anything that fancy anyway. So let's take a look at instruments, see how to use it, and then we'll run it on actually, let's just straight run it on some of my code. So yeah, so we've got some nasty looking code here from me. So let's just take a look at instruments, and then we'll see what we can run it on. If we'll run it on my code. But so there are two ways of running instruments. You can actually launch instruments as its own little application, or from inside Xcode you can actually. So when you launch it the other way, you could then attach to a process and then record whatever's going on. You can also just launch it through Xcode. And say we're interested in leaks. And I think I may have done this the first day, and we found that my code, or we may have used the static analyzer, I don't remember. But let's just see if my code has any leaks in it. So we can, select that. This thing should already be built-ish, and it'll run. And we'll let it run for a little bit. And let's make it do something, and then we'll talk about what it is that's going on. Okay, so earlier instruments wasn't really working for me, so let's see. Something seems wacky right now. So, okay. So Hello Davis. Let's go ahead and search. You know what? Let's put in a few more. Man, something's up with the thing. Okay. Yeah, my machine's not being very responsive at the moment. Let's see what's going on. Okay, so we'll hit search and let's see. Again, this is usually much faster, so I'm kind of concerned as to what's going on. So instruments, it's doing its thing. All right, well, while this tries to figure out whatever it's figuring, oh, there it goes. Okay, so let's do some other stuff. Let's scroll some things around. So yeah, I don't know, I could be low on memory and just had a bunch of stuff that needed to swap. So I don't know, we'll just click on a few things, click on something else. We'll go back over here. Let's use the French dictionary instead. Okay, so we'll stop recording and see what we see. So first of all, when you use instruments, so again, we're talking about performance. So generally, so what I've done right now is we're looking at memory allocations and memory leaks. So there's this object alloc and leaks. When you're doing performance analysis, generally you want to be doing the performance analysis on on the device that you plan to ship to, because when you're running in the simulator, what's happening is, while you're exercising the same sort of memory allocation patterns and you're utilizing the same API as the actual device, what's happening is the simulator is using your beefy machine's graphics card. It's, it's 10 cores, so whatever it has inside of it, it's making use of that. So when it comes to certain types of performance, or when analyzing certain types of performance, you definitely want to be on the device. When you're talking about things like object allocations or memory leaks, those aren't going to change whether you're on the device or on the simulator. So because of the type of overhead that is associated with maybe keeping track of memory leaks and stuff, it might be better to just run that sort of stuff on the simulator. So that, and then there's also some file I/O types of checks that you can look at. Again, those access patterns are going to be the same no matter what. If you're now, if your application does all sorts of math and you're actually interested in the CPU performance, then that's something you want to do directly on the device. So, all right. And I guess while I'm talking about that, so in this case, I ran the leaks thing, which added these two types of instruments, this object alloc and leaks. So there's this little library that you can bring up, and you'll see a number of different types of instruments that you can set up. So there's some memory things, and I'm missing some things at the moment. So usually these are, I thought, were separated into I felt like they were broken out into like iPhone specific versus just general OS X stuff. But so here's like the time profiler to take a look at some things. And I'm not seeing, there's OpenGLES is somewhere in here as well. So I'm not sure what's going on in terms of my library, but we'll worry about that later. So as far as object allocations, so we see oops. That's what I wanted. So unfortunately it took a while, and usually I'd expect to see some bigger spikes and stuff, but if we look, we'll see that, you know, as the application was starting, I had some sort of something going on where there was a little bit of a spike, and then we went on. Maybe I should rerun it because of the weird stuff that was going on. Later on it seemed like there was another tiny spike right there. Usually you'll see stuff that's kind of like, you know, it'll hit the ceiling when it's really bad. And then I guess it went for a while we were trying to figure out what the heck it was doing. And at the very end, when I switched to the French dictionary, there was this other large spike. So let's see what was going on at the beginning. So you can grab these little slider, this little triangle guy, and make a window. So select the left side of it, and then I don't know, let's just grab all this and see what was going on. Select the right side of it, and what that'll do is just, you know, limit you to sort of what's going on here. So let's see if there's anything really terrible going on. So if we look down here, we'll see, you know, all of the allocations. So it's saying that there are 695K allocated total. So that's kind of nothing. That's nothing really terrible. So I don't know. I'm not seeing anything too exciting with that. Let's see. Let's just select something just to get some info and see some more about what's involved here. So you have a few different views. There's sort of this detailed view, and then there's this additional extended view. And usually, so in this extended detail, and what I did, I drilled down into this, all the places where the strings are being allocated. You'll usually get some sort of a stack trace, so you can see where things are happening. And looking at this point, I'm not seeing anything again too exciting that's worthy of showing anything off. All right. So the point being, as you're running your application, if you're running leaks and you're looking at object allocations, you'll see this graph. And, you know, as you're pressing on things, occasionally you'll see spikes. And what you probably don't want to see is something where you just keep seeing this graph grow. So in my case, what we see is that, at least in this barred area, we see that I did some allocations, and then it looks like I freed the memory, because as we kind of moved on over here, we didn't really see much going on. And then there was another little spike, and it went away. Another little spike, and it went away. Another, you know. So for me, in general, I feel like, okay, I'm not doing too bad. So I allocate some memory, I do whatever I need to do with it, and then I get rid of it. The bad situations would be when basically you just see this continuous graph, and it just keeps growing and growing and growing. So for some reason, you're just grabbing a lot of memory and not letting go of it. As far as the leaks go, you know, if we look at this graph here, we see that some leaks were discovered right around here, and, you know, as time goes on, we see that, you know, the number of leaked bytes is staying sort of constant, and then I did something else, and there seemed to be another little leak, and then the number of leaked bytes just sort of stays constant. So it doesn't really seem like I'm really leaking a terrible amount of memory. I'm kind of surprised I'm leaking any, but I was surprised before, and, you know, that's where these tools are nice, because, you know, you never know. So let's see if we can find what is being leaked. So If we look down the side, we see some malloc things, some addresses. So again, not really seeing anything too terrible, but so I've got. So in this case, it seems like I'm accessing an STL vector somewhere. So let's see if we kind of click on this little arrow here, we should get some more additional information. And so we have our call stack. So if we look through the stack and we scroll on down a bit, what do we have? So that's interesting. So if you double click on one of those things, you get, and there's also like a little button. Well, if you double click it, you'll see some of the code here, and then there will be some links so you can sort of trace deeper into the code. And then there's also a little button here, if you look closely, that'll take you right into Xcode. So in this case, what I'm doing is I run analytics on my applications to see, to see what's going on, and I'm using stuff from a company called Pinch Analytics, and this is part of their setup where they have this beacon thing, and you set it up, and it almost seems like somehow I'm leaking with this thing, but I don't really have much control over the beacon stuff, so it's hard to say what's going on with that. So I think what I'm going to do is I'm going to run it one more time and go to a screen that I remembered from the first time that was leaking some memory, and it's a screen that pretty much nobody ever goes to, which is the About screen. Yeah, something's funky. Something funky is going on with my stuff. It doesn't generally ask me for this sort of stuff, but let's see. Okay. All right. So, as we can see, the tools aren't perfect. They have issues sometimes, but I'll run it one more time with leaks, and then we'll run it with the CPU sampler so we can see some stuff, hopefully. But I want to see. Okay, things loaded up much faster this time around. Okay, same sort of stuff. Click around on a few things. Let's change. Okay, we're French. Let's change to an English one. We should see a little spike. Search again because it's got a different dictionary. And let's click on support, and that's where I expect to see some leaks happen. At least I did before. Maybe I fixed it the last time we did stuff. Alright, well, I guess my code is just not leaky in the way I'd hoped it would be for a demo, which I guess is good in the end. But let's see what we see. Yeah. All right. Well, again, we saw as I was doing some things, the allocations kind of jumping up and down. The leaks themselves, I think I'll have to look a little closer to see. I don't necessarily believe some of what I'm seeing. So at the bottom we have a few different views that we can look at, and again, just something to kind of play around with when you start messing with these tools. This detailed view that we saw, and then some of the code. Yeah. All right, well, a simple thing we can do, of course, we can just jump into one of the sample applications I've done, and we could, you know, make a loop and make it leak, and we should see that it leaks, and then if we get, but we won't go through that. I'll just leave it. Oops, I want to stop. So let's take a look at, so let's run the performance tool with the CPU sampler instead and see if we see anything interesting there, at least for this particular application. So, all right, we saw a spike at the beginning on startup. I'm going to put in a few more of these because that'll make it work really hard. So we see I hit search, and that thing jumped up, and now we're done. Rotate, or I fly through these things, nothing much really happening as far as the CPU is concerned. Nothing too crazy. So we'll just stop there and see what we see. So again, it seems like most of the interesting stuff's happening over here. Again, let's just put a window around that so we can just sort of focus on some of those things. So here's where things get a little interesting with when you first start using instruments and you start trying to figure out what does all this stuff mean. So if we look, basically we've got these samples. So the way instruments works is it does this statistical sampling where, based on some settings, probably in here maybe, for example, it samples, in this case, at this 10 millisecond rate. So what happens is every 10 milliseconds, instruments basically just takes a snapshot and looks at the stack and says, okay, well, what's on the stack? Okay, this particular function is on the stack, so let me increment some counters for it. So it's just doing this sampling and this timing. So if we look right now at sort of the default setup, we have this all sample count set up, and we see that 1,600 samples were spent in this mock message trap. And people always wonder, it's like, oh, what is this mock message trap? What's it all about? And that's actually just it's sort of, it's the thing that's waiting for events. So it seems like a lot of time we're not really doing that much. So it just happens that function is on the stack and being sampled. So it's gotten a lot of samples. Just because it has a lot of samples doesn't mean that there was a lot of time necessarily spent there. So if we go ahead and click on the running sample times, we should see some things a little differently. And in this case, we see that I seem to be spending a lot of time in this zone-free definite size. So if we select that, we can look at this detailed view. We can get a stack, and we can see through some of my code that some of what I'm doing. Let me stretch this out a little bit. And yeah, so what you can do, you've got this little triangle guy here. If you press Option and triangle, it'll just expand the entire thing, so you can see sort of everything that's going on. And these PWEs here, this is a namespace for some of my stuff, and it's the PWE, the Peanut Word Engine, which is where I have some things. So it looks like I'm doing some stuff recursively, so we can see that it's kind of I'm just calling a bunch of different things, and in this case it's all the same method because the way I'm solving whatever it is I'm solving, I'm doing it in this recursive way. And it seems like what's happening is eventually basically a bunch of things get allocated and then a bunch of things get freed. And let's see if we look in the code. All right, again, something wacky's going on. Okay. So let's see if we can see where, well, I don't know if that's the best thing to do, but let's see. So again, I think it would take a little more time to kind of look through some of this, but I guess the important part is to know that, looking, so you can look at these views and you can see that so when we look at the runtime, we see that, okay, a lot of time is being spent deallocating stuff. So that's something I should look at in terms of how I'm, if this was actually an issue in terms of performance, which, when the user does run this on the phone, it might take a few seconds depending on how many letters they've used and how many question marks, which represent blanks, they've placed. So that's something I might want to look at, is this free stuff. But again, it doesn't seem like really that, 8.7% of the runtime doesn't really seem like it's that crazy. And I'm calling to upper quite a bit, so maybe there's a different way I can do some things so I can avoid having to ever call to upper. So it at least will give you some ideas of the places to look to kind of see what's going on. Some other things here on the side, you can look at the various threads that are running. I'm not running multiple threads, but some of those other ones are just the system threads. So, if you're just interested in the main thread, you can focus on just that. Inverting the call tree, again, just sort of changes how things are displayed. So usually when you call into functions, eventually you end up at some leaf place. So inverting the call tree will sort of put the things that were kind of at the bottom up top, so you can look at them a little more easily. So I don't know. I haven't ran into too many folks, at least not in office hours, that have been having performance issues. I guess we'll see as people come in towards the end. Definitely, get your things working, and then at some point run the performance analyzer, and you'll at least get a feeling for where some funny things are going on. Again, I'm not sure, maybe because this application doesn't do any OpenGL stuff, it's not showing me some things, but I'm going to quit this and see. So usually when instrument starts up, it should drop a sheet. Okay, so these are some of the things that I was hoping to see. So things are they're broken down. So the things you can do for OS 10, if you're doing an OS 10 app, things you can do for the iPhone, and they've sort of separated out as well. So looking at the simulator. So when it comes to graphics stuff, if you're using Core Animation, which we didn't really discuss, you can use that to help you figure out some things. OpenGL ES, again, to just give you some insight into what's going on with OpenGL. The file system, so if we ran this on my application prior to some optimizations I made, you would see that it's hitting the file system a lot. And I did something where I got rid of that, and my performance increased by 10x. And again, CPU type stuff, so looking at just what the CPU is doing as you're running. There's one in here which I'm not seeing because I think it has to be on the simulator. So an interesting one, that if you're running your code, your application, and you're getting these weird crashes, and it seems like they're happening in something that's Objective-C _ message send, that could be a hint that what you're doing is you're over-releasing something and then sending it a message. So what you can do is you can set up these, you can use this zombies thing, and when Instruments is running, what it will do is it will sort of basically the objects that you release, it won't actually release them, it'll sort of hold on to them in its own little way, and it'll track that the retain count is being decreased, and at some point, if you try to send a message to an object that's been released, you'll get this zombie thing that'll kind of pop up and tell you that, hey, you're trying to send a message to this zombie object that's been removed. So again, when it comes to like some of the performance analysis stuff, there'll be some things that will sort of pop out at you that will be fairly obvious. There are other things that are a little more difficult. So doing performance analysis and tuning and stuff, there's sort of a bit of science to it, but then there's a lot of art to it in terms of knowing, well, what is it that I'm really seeing? And okay, now that I've seen this, what can I do about it? It seems like everything's happening in stuff that's not my code, or it's happening in Apple's things. And then making the realization, well, it's happening in Apple's things because I'm just calling it Apple stuff way too often, for example. So I think I'll leave it at that, and then I don't know, I'll stick around until 6, so for a little bit, and I don't know, I had a few people in office hours today as we went through various crazy bugs, so I'll stick around and try and help people find whatever I can help them find, and yeah, we'll leave it at that. So thank you.